All right, so we'll be looking at the methods of charging the gold leaf electroscope. Method of charging the gold leaf electroscope. Remember, we said that we can use electroscope to one, detect the what? The presence of a charge on a body. Secondly, we can use it to what? To know the nature of the charge on a body. And thirdly, we can use it to what? To distinguish between what? Conductors and insulators. But before we use our gold leaf electroscope to do any of this, we need to first of all charge the what? The gold leaf electroscope, either positively or negatively. All right, so for us to charge the electroscope, now there are basically two methods of charging the gold leaf electroscope. And these two methods are the contact method and the electrostatic induction method. All right, so by contact method, now, just like the name implies, now a body that is charged either positively or negatively is brought in contact with the what? The brass cap of the what? The gold leaf electroscope. For instance, let's say this body is positively charged and this is the what? The cap of my gold leaf electroscope. So I will bring this positively charged body in contact with the what? The brass cap of the what? The device. And as a result of that, now some charges will be found to what? To flow from the charged body down through the what? The brass stem and then to the what? The bottom, which is the what? The gold leaves. And then the leaves will be found to what? To diverge as a result of this, showing that what? Some charges have truly been what? Being passed down to the what? The device. And you do that for a short period of time, and then the device, or sorry, the charge body will be what? Will be removed. And the the charges that will be left on the electroscope is going to be the same as what? The charges on the what? On the body that have what? Brought those what? Charges. Meaning that if the body is positively charged and I brought it in contact with the charge of the what? The cap of the electroscope, then the electroscope will be what? Positively charged. If I should use a negatively charged body, then the charges on the electroscope will also be what? Negatively charged. So that is what takes place in the what? The contact method. Now, secondly, for us to charge the electroscope, we can also use the what? The electrostatic induction method. And what do we actually mean by electrostatic induction? Now, by induction, we mean the what? A process of what? Of charging a what? A neutral body by bringing it what? Closer to the body without actually coming in contact with the what? With the body. Are we together? So that is what it means by what? Induction method. It means that in this method, the two bodies will not come in contact, but it is just brought near to it. And one body will be found to what? To induce some charges on the second body. So that is what we mean by electrostatic induction method. So the next question is, how do we charge our gold leaf electroscope through this electrostatic induction method? Now, we require basically 4 steps in order to charge our gold leaf electroscope through the electrostatic induction method. Now, and one important thing we need to know is, in this method, if you want to charge the gold leaf electroscope positively, then you have to use a what? A negatively charged body. And if you want to charge the gold leaf electroscope negatively, then you need to use a what? A positively charged body. So that is how the electrostatic induction method works. All right, so just like we said, we require 4 steps. Now, what are the 4 steps? Now, the first step is, let's assume we want to charge our gold leaf electroscope positively. That means that we need to use a what? A negatively charged what? Body. So the first step is to bring your what? Your negatively charged body. Let's say this is my negatively charged body, and this is the cap of my gold leaf electroscope. So I'll bring the what? The negatively charged body and bring it closer to the what? The cap of the what? The gold leaf electroscope. Remember, they will not come in contact because it is what? Electrostatic induction method. So once that is done, now of course we know that the body is negatively charged, and that will make what? It will attract all the what? The positive charges that are at the what? The brass cap of the what? The device. And it will repel all the what? The negative what? Charges, and which are the what? The electrons. Remember, from the fundamental law of electrostatics, we say that what? Like charges what? Repel, while unlike charges what? Attract. Meaning that right from the onset, the gold leaf electroscope is a neutral body. Are we together? It is a neutral body. And then I'm bringing a what? A negatively charged body closer to it. So it means that that negatively charged body has every tendency of what? Of attracting all the what? The positive charges. And it will what? Repel all the negative charges. So once the negatively charged body is brought closer to the what? The cap of the gold leaf electroscope. It attracts all the positive charges, and then it now what? Repel all the negative charges, which are the electrons. So these electrons that are repelled at the cap will be forced to what? To flow down the stem of the device and then go down to the what? The leaves. And the leaves will found what? To diverge or to open as a result of that. Meaning that some what? Some charges have been what? Be passed down to the leaves. So after this is done, what do we do next? Now the next step is for you to what? To earth the what? The gold leaf electroscope. By earthing we mean by what? By touching the what? The cap of the what? The gold leaf electroscope with your finger. Remember that the human body is also a what? A conductor. Although not a good conductor, but the human body conducts what? Electricity to some extent. So by touching the what? The cap of the what? The gold leaf electroscope, while the negatively charged body is still held closer to the what? The device. Now that will force those negative charges that have been pushed down to the what? The leaves to what? To be conducted away from the what? The gold leaf electroscope entirely through your what? Your finger. So it means that those charges that are what? Negative charges that have been pushed down to the what? The leaves will now be forced to what? To flow out of the gold leaf electroscope through your finger and then through your body and then down to the what? To the earth. So once that is done, now the gold leaf electroscope or the leaves will be found to what? To close as a result of this. Meaning that those negative charges that have what? Actually passed down the what? The device have actually been conducted away from the gold leaf electroscope. So once that is done, the next step is for you to what? To remove your finger. Now you don't remove the what? The negatively charged body while your finger is still there. So the next step is you need to what? Remove your finger that you use to what? Earth the device. So when you remove your finger, now lastly, you now what? Remove the negatively charged body. So when you remove the negatively charged body, now a net positive charges will be left on the what? On the cap of the what? The gold leaf electroscope, because all the negative charges have been what? Be conducted away from the device through your finger down to the what? The earth. So when the negatively charged body is removed entirely, now the net positive charges will now spread across the what? The cap of the what? The gold leaf electroscope. And the electroscope will again what? Open as a result of this. So this is how you charge your what? Your gold leaf electroscope through the electrostatic induction method. All right, so the next thing we will be looking at are the uses of the electroscope. We already itemized the uses of the gold leaf electroscope. We say we can use it to what? To detect the presence of a charge on a body. We can also use it to what? To know the nature of a charge or the type of charge on a body. And thirdly, we can use it to distinguish between conductors and insulators. All right, so how do we know use the gold leaf electroscope to test the presence of a charge on a body? Now, when your electroscope is charged, for instance, your electroscope is either positively charged or it is negatively charged. And then when you bring a body of which you want to test whether there are charges in the body or not, when it is brought closer or in contact with the cap of the gold leaf electroscope, if there is a divergence in the what? In the leaves of the gold leaf electroscope, it therefore means that what? That body that you brought in contact with the cap of the gold leaf electroscope has some what? Some charges in it. All right, so that is how we can what? Know the what? That the material has some charges in it. And the degree of the divergence of the gold leaf electroscope or the leaves determines what, or is a measure of the what, the amount of charges that are actually in that body that you what, you brought in contact with it. Now, so that is how you can know whether there is a charge on your body or there is no charge on the body. Now, secondly, we say we can also use the gold leaf electroscope to know the nature or the type of charge on a body. Now, for instance, we already know that when you place a charged body closer to the cap of a gold leaf electroscope, now we know that the electroscope is going to diverge, meaning that there are charges. But you don't actually know that if those charges in that body you brought in contact are actually negative charges or they are actually what? Positive charges. Now, how do you use the gold leaf electroscope to test for that? All right, so when you bring, for instance, uh, a positively charged body, for instance, you don't know that the body is positively charged, but then you brought it in contact with the cap of your gold leaf electroscope, and the divergence of the leaves increases. If the divergence of the leaves increases, it means that the charges on that body you brought in contact with the gold leaf electroscope is the same as the charge in the gold leaf electroscope itself. Remember that the gold leaf electroscope must first of all be charged, either positively or negatively. So if you bring a positively charged body closer towards the cap of a gold leaf electroscope, of which you know that the charge on that gold leaf electroscope is positively charged. So if the divergence of the leaves increases suddenly, it means that the charge on that body is what? The same as what? The charge on the gold leaf electroscope. And the divergence there signifies the what? The repulsion that is taking place between the what? The two bodies, because they are actually what? Light. Now, similarly, when you bring a negatively charged body in contact with the cap of a positively charged electroscope, now what will happen? The divergence what? Reduces. The divergence will what? Will reduce. Now, what does that actually mean? The reduction in the divergence signifies the what? The attraction that is taking place between the charges in the gold leaf electroscope and the what? The charges on the body. So they are actually what? Unlike. So they will tend to what? To attract. So the divergence will what? Will reduce. Similarly, if your gold leaf electroscope is what? Negatively charged, and then you bring a what? A positively charged body. Of course, the divergence will what? Will reduce, because both charges are what? Are unlike. Similarly, but if the charge on the gold leaf electroscope is negative, and then you bring a negatively charged body without knowing that it's negatively charged, then the two bodies will what? There will be a great divergence, meaning that what? That the two bodies are actually what? Like. Meaning that what? They will actually repel each other. So that divergence there signifies the repulsion that is taking place between the what? The two bodies. That is the charge on the body and the gold leaf electroscope. All right. Now, similarly, when you bring a neutral body, for instance, the body is neutral. You don't know whether it is positively charged or it is negatively charged. But all you know that there are charges in that body. And you bring it closer to the cap of a positively charged electroscope. Now, the divergence will as well what? Reduce. The divergence of what? Will reduce. Meaning that what? The body is also what? Neutral. Similarly, when you bring a neutral body in contact with the cap of a gold leaf electroscope that is negatively charged, divergence will also what? Reduce. So when you look at the both cases, when the body was neutral, the divergence reduces. When the charges on the electroscope, for instance, is positive. And then when you bring a neutral body, and when the electroscope, the gold leaf electroscope is what? Is negatively charged, the divergence also what? Reduces. So it has the same effect as bringing a what? Opposite what? Charges closer together. Because in both cases, the divergence will tend to what? To reduce. So it means that if you bring your gold leaf electroscope is, for instance, positively charged, and then you bring a what? A negatively charged body closer to the cap Of course, we know that the divergence will reduce because they are actually unlike. And then when you bring a neutral body, it doesn't have any particular charge in contact, the divergence still reduce. So it means that the reduction there does not actually give you the nature of the charge on the body. It does not give you the nature of the charge on the body. So it means that the true test for the nature of the charge on a body is the increase in the divergence of the leaves. Meaning that if I have my gold leaf electroscope that is positively charged, and then I bring a body that I don't know the charge on the body, is brought closer to the gold leaf electroscope, or it is brought in contact with the cap of the gold leaf electroscope, and the divergence suddenly increases. It means that the body I brought in contact with the cap of the gold leaf electroscope is the same as the charges that are in the gold leaf electroscope. So it means that, for instance, if the electroscope is positively charged, it means that the charge on the body is also positive. Similarly, if the electroscope is negatively charged, and then I bring the uh, 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 a negatively charged body in contact with it, the divergence will of course increases. So when the divergence increases, it's telling me that the charge I brought in contact with the body is the same as the charge in the electroscope. So therefore, the true test for the nature of charge on the body is the increase in the divergence of the leaves of the electroscope. So a table has been prepared for you on the notes that will give you a general concept on how the divergence increases and reduces. So lastly, we will be looking at how do we use the gold leaf electroscope to distinguish between conductors and insulators. For instance, we know that some materials by their nature, they are good conductors, and some materials by their nature, they are poor conductors, and some materials are bad conductors, or they are insulators. All right. Now, when you pick a good conductor, for instance, you just pick a random material. Let's say you pick a random material, and you don't know whether this material is it a good conductor, or it is a poor conductor, or it is even an insulator. Now you can actually do that with the help of a gold leaf electroscope. Now when this random material is picked and then it is brought in contact with the cap of a gold leaf electroscope. Now if the divergence in the leaves of the gold leaf electroscope now diverges very fast, that means rapidly. It means that the conductor or that material that you brought in contact with the cap is a what? Is a conductor. So if the leaves diverges very fast, it means that that material is a what? Is a conductor. Now similarly, when you bring the random material in contact with the cap of the gold leaf electroscope, and the divergence in the leaves is very slow. That means that it diverges slowly. It's telling you that the material you place in contact with the gold leaf electroscope is a poor conductor of electricity. And then when you place a random material similarly on the cap of the gold leaf electroscope, and then there is no any observable divergence in the leaves of the gold leaf electroscope, it means that that material is an insulator or a bad conductor of electricity. So basically, you can actually distinguish between conductors and insulators by the speed of the divergence of the leaves of the gold leaf electroscope. So we are going to stop here for now. Check the next video for the ways of producing charges.